Let us try this problem number 61 of your textbook. This problem, carefully, this problem I have found a little lengthy. So we go carefully step by step. It says a small body of mass m, this is that small body, is placed on a larger body of mass capital M. And the shape of the larger body is given. This left end is vertical and the right end is horizontal, whose surface is M, whose surface is horizontal near the smaller body and gradually curves upwards to become vertical at the other end. Fine. Now, what is the work done? What is the job done? The smaller body is pushed on the larger one with a speed v, and the system is left to itself. That means the smaller body is pushed with a velocity v, and the system is left. Assume all surfaces are frictionless. That means this surface is also frictionless, and this surface is also frictionless. Then its first question is, find the speed of the larger block when the smaller block is sliding on the vertical part. This smaller block will gradually come here, then it will come here, then finally smaller block will climb up the vertical part, provided of course this has got sufficient kinetic energy. Now, smaller block has a momentum, and this momentum will be passed on to the larger block also. And mind it, here, the smaller block remains attached to the larger block. So the problem is a kind of a problem of perfectly inelastic collision. That is where the final velocity pertains to both the blocks together. And initial velocity is the velocity of the smaller block only. With that concept, we start first. Right? So let us attack the part A first, where actually this is the larger block and the smaller block is somewhere here. Right? Now, this is M, and say both together moves with a velocity v1. Say blocks together left velocity v1. Then obviously from the conservation of momentum, the v1 multiplied by the total mass, capital M plus small m, will be equal to the momentum of the smaller body, mv, because that is where it started. From here, we can easily find out v1 is equal to small m divided by capital M plus small m into. This is the first answer. What is the speed of the larger block when the smaller block is riding on its vertical part? But mind it, this is not only this is the speed of the larger block, this is also the speed of the larger block as well as the smaller block together. Second question. Find the speed of the smaller block when it breaks the larger block at height h. This is the height h. So let us go to part B. Let's go to part B. There is a time when actually this is the capital M, and the smaller block will leave the larger block. Now mind it, the smaller block was going up vertically. So it will have a vertical velocity. And also it had a horizontal velocity. The velocity with which it was going towards left along with the larger block. So let us say this is its resultant velocity. Let us say this is the resultant velocity V2, the smaller block when it breaks off. Say resultant velocity of M and it breaks off, when it breaks off is equal to V2. And V2 has some angle with the horizontal or with the vertical normal that we do not need right away, right? So if we consider the energies, kinetic energies, initial kinetic energy of the smaller block was half m v square. Energy started everything. This kinetic energy, half m v square, this started everything. And this has resulted into some other components of kinetic energy, so kinetic and potential energy. One component of the energy is the half capital M V1 square. This is the kinetic energy of the larger block. So shall I write? Let me write here. Okay, I will write later on. Plus half small m V2 square plus mgh. If we write them, what are they actually? What are they? This is actually kinetic energy of the smaller block of from where it all started, equal to this is equal to kinetic energy of the larger block. This is equal to kinetic energy of the smaller block when it breaks off, plus this is equal to potential energy of the smaller block. I think you will agree with me. This is the potential energy of the smaller block. This is the kinetic energy of the smaller block. And this is the kinetic energy of the larger block when the break-off occurs. And the source of all these energies is actually the original kinetic energy of the smaller block M. Right? So from here we get, from where you get half m v squared. So we can, from this equation, from here we come here. So m v square we multiply by 2 is equal to capital M v1 square plus small m v2 square plus multiplying by 2, 2m gh. So now I can remove all m's. I cannot remove really m because then I have to divide it by small m. Divided by small m. This small m is removed. This small m is removed. So what I am left with, this square is equal to capital M by small m, v1 square plus v2 square plus 2gh. Now, what I am trying to find out, I am trying to find out V2. I'm trying to find out V2. So from here, we write, therefore, I go to a little left so that some space is available. So V2 square, this is the V2. V2 square is equal to V square minus capital M by small m V1 square minus 2GH. From here, we get this is equal to, I get here, this is equal to V square minus, now I shall put the value of V1, capital M by small m. What is the value of V1? Value of V1 is given here. And I have to take V1 square. So this multiplied by small m square, V square divided by capital M plus small m whole square minus 2GH. This is equal to this small m, one of the small m will get cancelled. This small m will get cancelled with m square and only one m will remain with me. So this is equal to v square. Now if I take v square in common, so v square I take inside the bracket, 1 minus, this is capital M, small m, capital M, small m, divided by capital M plus small m whole square minus 2GH. This is equal to v square. Now, I further simplify this. The denominator, I have capital M plus small m whole square. The numerator, I will have capital M square plus small m square plus 2 capital M small m minus 1 capital M small m minus 2GH. This will be equal to v square into capital M square plus 2mm minus 1m. So I'll have only 1 capital M small m plus small m square divided by capital M plus small m whole square minus 2GH. From here, I find this is V2 square. This is V2 square. Remember, this is V2 square is this. This also will need in further deduction. And for to give you the result, as the paper setter wanted, V2 is equal to under root of this entire expression. Capital M square plus capital M small m plus small m square divided by capital M plus small m whole square into, there is a v square here, v square minus 2GH whole thing to the power of. This is they wanted us to find the speed of the smaller block when it breaks from the larger block of height h. This is the V2. This is the speed V2. And we have found the value of V2 is given here. Fine. Now, what is the next question? Next question says, find the maximum height that the smaller block ascends. We have seen the smaller block lifts the body with a velocity with a little angle towards right. This will have a vertical component, of course. This vertical component will take it upward. That is question number, it was C. That was question number C. C. C is, this is the bigger block, and the body has detached from here with a velocity v2. Right? Now, this will have a vertical component which we call Vy. And this will have a horizontal component which we call Vx. Or no, sorry. This will have a horizontal component. This component, horizontal component, is actually the velocity of the bigger block V1, which we have already deducted. I repeat once again, when the body just detaches from the main body, bigger body, then its horizontal velocity was at that instant, of course, the velocity of their combined velocity V1 that we have already deducted. And it has got a vertical velocity Vy, and their resultant velocity is V2, which we have already found out the expression of V2. From here, we find, of course, V2 square is equal to V1 square plus Vy square. This is clear. So therefore, Vy square is equal to V2 square minus V1 square. Because they want us to find out what height it has reached. In order to find out what height it has reached, I need to find out what is the value of Vy. So we can now find out the value of Vy in this fashion. We can now find out the value of Vy here. Vy, now Vy square is equal to V2 square minus V1 square. So now let us deduct it very carefully. So Vy square, because the expressions are very cumbersome, Vy square is equal to V2 square. V2 square we have already found here. V2 square is m square, etc., etc. So we repeat this equation: m square plus m small m plus small m square divided by capital M plus small m whole square, and there was a v square minus 2gh. This whole thing is v2 square minus v1 square. Now, what is the value of v1? We found it out at the very beginning. V1 is small m by capital M plus small m into v. So, using this value of v1, we write the value of v1 is small m square v square by capital M plus small m whole square. This is equal to, we take v square as common from these two terms. V square as common from these two terms. V square you take a common, then from here I have capital M square plus small m square plus capital M into small m, that divided by capital M plus small m whole square minus, from here I have small m square divided by capital M plus small m whole square. The second bracket is closed minus this term 2gh. Minus this term 2gh. This is equal to v square. We continue this. We both have the same denominator. So since both has the same denominator, and further simplify capital M plus small m whole square. In the numerator, we have capital M square plus small m square plus capital M multiplied by small m minus I have a small m square. So second bracket closes here, minus 2gh. Minus 2gh. This is equal to, now this small m square and small m square gets cancelled. So this is equal to v square. This is equal to v square multiplied by, here it is again capital M square plus capital M small m. So I take capital M common. So I have capital M plus small m. This divided by capital M plus small m whole square minus 2gh. This is equal to, now in the numerator I have m plus m, in the denominator I have m plus m whole square, so I am left with v square capital M divided by capital M plus small m minus 2g. Right? So this is the vertical component of the velocity. But they have not asked for the vertical component. They have asked for the what maximum height it reaches, right? But we have found out the vertical component because otherwise we cannot find out the maximum height reached by it. So with this vertical component, it say the maximum height, say I go to the drawing, say from here, it goes to the maximum height of h1. Say this vertical velocity vi, the block, small block, climbs a further height of h1. Why I said further height? Because it was already at a height of h. So I said further height of h1. If it rises another further height of h1, then of course by the kinetic energy, so from energy equals, so from conservation of energy, when it started flying, its energy was half m, its energy was half m vy square, right? Now, its energy was half m vy square. And with this energy, it has risen or climbed to another height of mgh1. From here, we find h1 is equal to m gets cancelled. h1 is equal to vy square by 2g. vy square by 2g. So total height, so total height climbed by the block is equal to h plus h1. h plus h1 is equal to h plus vy square by 2g. Vy square by 2g. Now, we have found Vy square is given here in this equation. So, we just put this value, Vy square by 2g. So, this will be V square m or mv square is equal to h plus capital M V square divided by capital M plus small m, that divided by 2g, minus, there was a 2gh here, 2gh divided by 2g. So h becomes, so this is, sorry, so this is not h. I should not write h equal to, I should write, so this is equal to then, this is equal to h, is continues to be h plus mv square by this. So if you, here you see 2g, 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 2 cancel. So I am left with h, another minus h. So whole thing gets cancelled. So what I am left with is, whole thing gets cancelled. What I am left with is capital M V square by capital M plus small m into g. This is the answer to the question that find the maximum height reached by the smaller. This is the answer to the question, maximum height reached by the smaller. Now there is a part D. There is a part D of this question. As I said, this question is really lengthy. What is the part D of this question? Part D of this question is, part D of the question says, show that the smaller block again will land on the bigger block and find the distance traversed by the bigger block during the time when the smaller block was in flight under gravity. The first point is show that the bigger block, the smaller block will again land on the bigger block. This first, answering the first question is rather easy if you think of it a little bit. See what happened really. What happened really? This bigger block, capital M, was moving towards left with a velocity. And at certain point of time, this one, having a velocity in some angle, it took a flight. And the questioner showed that the smaller block will again land on this. Now, during the time it is on flight, like this, the bigger block continue moving. Where will it land? Continue moving. It may happen that the bigger block has come so far away, the smaller block drops on the ground, or the smaller block goes on the other side. But no, this will not happen. This problem is just like you have always seen if you are traveling in a bus, and if you have a ball in your hand, if you throw the ball upward, the ball comes back to your hand because the ball already had a horizontal component of velocity when you threw it upward. And that horizontal component of velocity is the velocity of the bus. So by the time bigger, smaller block drops down, the bus moves the same distance, right? So we can write here with some argument, since horizontal component of velocities of small m and bigger m are same. So small m will drop back on the bigger block. Not only it will drop back on the bigger block, it will drop on the same spot at the same spot. That means the picture will be like this. That means if we draw the picture like this, I shall draw the picture once again. That means what will happen? Say this is the bigger block, and the bigger block moves back here with its velocity, and the smaller block will fly and come back to the same spot again because they have the same horizontal component of velocity. Now, the question was how far this will move, what distance this will move when the smaller block was under gravity. Say this distance is d. They want you to find out this distance, right? Now, critical velocity. Now, let us first find out the time t, the time of flight. So, what do you do? The time of flight, we can say vertical component of smaller block, vertical component of velocity of small m was dy, the value of which we have found out, right? And say it reaches the final highest point of flight in time t. Then from kinematic equation, 0 is equal to I minus gt. From here we find t is equal to vy by g. Vy by g. So total time of flight is equal to 2t is equal to 2 by g. Total time of flight is 2 vy by g, or let us give it a name, total time of flight, capital T, because then we shall have some comfort in writing. So capital T equal to 2t, the total time of flight is capital T, is equal to 2 vy upon g. The value of vy we have already found. So this is equal to 2 by g. Vy we have already found, which is given by m v square divided by capital M plus small m minus 2gh whole to the power half. This is equal to 2 by g. Simplify this. Capital M plus small m is capital M v square minus 2 into capital M plus small m gh whole to the power half. This is the total time t. We have to just find out how much this bigger body moved during this total time t. That should not be, although it is lengthy, but it is not difficult. So, the bigger body moved by this time, how much it has moved? It has moved by its velocity v1 multiplied by capital T. 1 multiplied by capital T is equal to v1 we have already found. v1 multiplied by v1 is, we have found at the very beginning. M small v divided by capital M plus small m, that multiplied by capital T is 2 by g, that multiplied by capital M v square minus 2 into capital M plus small m gh divided by capital M plus small m whole. This is also whole to the power half. This is also half. So this becomes 2 small m v divided by g, because this capital M plus small m and this one will go together. So 2 mv by g, that multiplied by capital M v square minus 2 into capital M plus small m g a, this whole to the power half, and at the denominator I have capital M plus small m and capital M plus small m whole to the power half. This becomes capital M plus small m whole to the power 3 by 2. Sorry, this got erased. This is capital M plus small m whole to the power 3 by 2. So this is the distance this body will travel. During the time, the small body was in flight. And of course, at the end of the flight, small body drops at the same vertical edge of the bigger block, because both have the same horizontal velocity at the time of breakoff. So there it ends. Now we shall go to the next problem.